Worksheet number 6, question 1, part A. It says if a student was chosen at random, what is the probability they want to play Scrabble and want to eat cookies? So in set builder notation, that's the probability that they want to play Scrabble and they want cookies. Looking at our table, we're looking at Scrabble and cookies. And because we haven't had the scope reduced by any kind of a given statement, we're looking at a total of 115 in our sample space. So the probability of Scrabble and cookies is 12 out of 115. Part B says if a student was chosen at random, what is the probability that they want to play Risk? So we're looking at all the people on the Risk line. There's a total of 23 of them. So that's 23 out of 115. In set builder notation, that was simply the probability that they want to play Risk. Part C says if a student was chosen at random, what is the probability that they want to eat pizza rolls or chips and dip? To answer that, we're looking for the total of the pizza rolls and the chips and dip. So we can add those two together and we get 85 out of the total of 115. The set builder notation for that was the probability of pizza or chips and dip. Question 2. Using the information in the table above, same table as question 1, calculate the following conditional probabilities. So this time, we have a given showing up in each of the probability statements. Given means as soon as we see it's given cookies, that means we're reducing our interest to just that area where just the cookies column. So part A, the probability of Scrabble, given cookies. So we've looked for the Scrabble number, and we're going to put it over the cookies number. Part B, the probability of pizza rolls, given that they're interested in Risk. So again, we look at just the Risk line. So we ignore everything else in the table. We focus just on the Risk line. The denominator becomes the total for Risk, and the numerator will be wherever the pizza rolls fall on the Risk line. So pizza rolls are 12 on the Risk line. So the probability of pizza rolls given Risk is 12 out of 23. Part C, what's the probability of Monopoly given chips and dip? So again, we're constraining ourselves to just the chips and dip column. We look at the total, which is 41. That's going to become our denominator. So we can put that in right away. Then we're looking for Monopoly in that chips and dip column. So we find Monopoly, it's 17. So the probability of Monopoly given chips and dip is 17 out of 41. Part D, the probability of cookies given they like Trivial Pursuit. So again, we're looking at just the Trivial Pursuit line. That tells us that the 29 is going to be the denominator, and the numerator will be wherever cookies falls on that line. So cookies on the Trivial Pursuit line is 7 out of that 29. So the probability of finding somebody who likes cookies, given that they like Trivial Pursuit, is 7 out of 29. Question 3, Part A. If a drill bit is selected at random from those that were inspected, what is the probability of choosing a wood drill bit? Well, the first thing we have to do is finish the contingency table. So we start off by looking at what can we complete right away. So we've got 540 and 34, but we're missing the total. So we'll go ahead and add those up, and that'll give us the total. So we've got a total of 574. Now we can also look at the not defective column. We've got 540, and we know the total has to be 1410. So we can do the math and come up with the missing figure there of 870. So 540 plus 870 gives us 1410. With the two numbers across the bottom, we know that the grand total of all the drill bits is going to be 1500. We've got 1410 here, so that means the piece of information for the defective bits is going to be 90. With that information, now we can go ahead and finish that column. We know that the number of wood bits and cement bits that are defective have to total 90. We've already got 34, which means that we need to have 56 more in that column. So the number of cement bits will be 56. We now have two ways of figuring out the last bit of missing information. We can either do the difference on the total column, or we can add up the rows and get it that way. Whichever way we choose to do it, we're going to end up with the same answer of 926. So 574 plus 926 gives us 1500. So we've finished up the table now. Now we can answer the question of if a drill bit is selected at random, what is the probability of choosing a wood drill bit? So in that case, we're looking for the total number of wood bits, which is 574, divided by the total number of bits, which is 1500. So the probability of a wood bit is equal to 574 divided by 1500. We could reduce that down further to 287 divided by 750. I honestly don't know if we can reduce that any further, so I'm going to leave it there. Part B says, what's the probability of finding a defective drill bit given that it's a cement drill bit? So we want the probability that it's defective given that it's a cement. So we're given that it's a cement drill bit, so we automatically know we're just looking at the numbers from this one line. So we can put the 926 as the denominator, and then the number of defective bits on that line is 56, which can also be reduced down further to 28 over 463. Part C, what is the probability of a wood drill bit given that it is defective? So we can look at just the defective column, and the defective total will give us our denominator. And now we just need the numerator, and we're looking for the wood drill bits. So it's 34 out of 90, which we can also reduce down to 17 out of 45. Question 4 expects us to build the contingency table to start. So the first piece of information they give us is that there are 20,000 people in total to deal with. So we can take that 20,000, and we know that that's going to go in the bottom left-hand corner because that's the total of that column and the total of that row. Then they tell us that half the sample get vaccinated and half of them don't. So that tells us that each row will have 10,000 in it. Then it tells us of this sample, 550 people who received the vaccine also contracted the flu. So I need to fill out my table just a little bit more here. First of all, I'm going to say that this column are people who got the flu, and these people did not get the flu. The top row is vaccinated, and the bottom row is not vaccinated. That piece of information says there were 550 people who received the vaccine who got the flu. So that's 550 there. Once we've got that piece of information, we can then finish up that row. We can figure out how many people didn't get the flu if they had the vaccine by subtracting 550 from 10,000. If we subtract that, we get 9,450. We're also told that 2,250 people who didn't get the vaccine got the flu. So those people are going to go into this cell here where they got the flu but didn't get the vaccine. Once we have that piece of information, we can also fill in this part of the row by doing subtraction. 10,000 minus 2,250, which is 7,750. We can then total up each of the columns, first the flu and then the no flu columns, 2,800, 17,200. Once we've got the table complete, now we can actually do the probabilities. So, part B1, calculate the probability that the person was vaccinated given that he or she contracted the flu. So the probability that they were vaccinated given that they got the flu. So we're given that they got the flu, so we know we're looking just at this column. So that tells us that we're going to have 2,800 on the bottom, because we got that from this part of the table. And we want the probability that they were actually vaccinated. So we take the 550 number and put it on the top as the numerator. So 550 out of 2,800, which could be reduced down to 55 out of 280. And I'm pretty sure we could reduce that down further to be 11 out of 56. B2. What is the probability that the person contracted the flu given that he or she was not vaccinated? What is the probability that they got the flu given that they were not vaccinated? So if they were not vaccinated, we're looking at the no vaccine line. Denominator is going to be 10,000, and we're looking for the probability that they contracted the flu. So we take the 2,250 number, and that can be reduced down to 9 out of 40. Part B3. What is the probability the person was not vaccinated given that he or she did not get the flu? So we're given that they didn't get the flu, so we're looking at that as our total. And the probability that they didn't have the vaccine is 7,750, which is 155 out of 344. Last part of B, B4, says the probability the person did not contract the flu, so probability of no flu, given that he or she was not vaccinated. So we're given that they were not vaccinated, so we're looking at just that row. So we know our denominator is going to be 10,000, and the no flu is 7,750, which can be reduced down to 31 out of 40. Part C asks us, the effectiveness of a vaccine corresponds to the probability that the person will not contract the flu vaccine given that he or she was vaccinated. So what is the effectiveness of this vaccine? If we write that into set builder notation, that's the probability that they don't get the flu given that they got vaccinated. To figure that out, we look for the vaccination line. So we're constrained to just looking at that line. So we know our denominator is going to be 10,000, and our numerator is the not flu piece. So in this case, we would say that the vaccine was 94.5% effective. Question 5. So it gives us a lot of information, and we're going to have to build up the table from scratch based on this information. So the first thing I'm going to do is rough in the table with all of the information we need. So let's go ahead and start filling in the blanks. It tells us that 50 students chose music, so we'll check that off, and we'll say that 50 students in total chose music, so that's our total for the music column. There are a total of 200 students entering grade 11, so that's our total. It's going to show up there. The probability that a student chooses art is 3 out of 5. So the probability of art is equal to 3 out of 5. We can then multiply that probability times 200, and that'll tell us how many students are in the art column in total. So art in total is 120. The probability that a student chooses home ec is 0.3. Similarly, we can figure out the total number of students in home economics. 0.3 times 200 is equal to 60. Now, we're given that a student chose home economics. The probability that the student chose art is 1 out of 4. So the probability of art given home economics is 1 out of 4. So as soon as we're given that it's home economics, we can now just focus on the home economics line. We're not interested in any other piece of data. We know that any information we're getting is just about that line. So that's telling us that 1/4 of the students who took home economics also took art. So we can take that art total, we can take the home economics total of 60 and multiply it by 1/4, which gives us 15. And that tells us how many of those people who took home economics also took art. Now we're told that the probability that a student chose law, given that the student chose art, is 2 out of 3. So the probability they chose law, given that they chose art, is 2 out of 3. So since we're given that it's art, we know we're looking at just the art column. So we know that we're dealing with a total of 120 students. So to figure out how many of those are law students, we can take 120 and multiply it by 2/3. And when we reduce that down, we end up with 80. So there are 80 students who signed up for law and art. Now the probability that a student chose music, given that the student chose home economics. Probability a student chose music, given home ec, is equal to 5 out of 12. Actually, before I get to that, I can now finish off the art line here. I might as well finish off figuring out how many biology students also chose art, and through simple subtraction, I can subtract 15 and 80 from 120, and I'll end up with 25 of those students taking biology. Now, back to the probability of them choosing music, given that they're in home economics. Again, I'm limiting myself just to the home economics line, so I'm looking at just that number 60. So I've got 60 times 5 out of 12, which is equal to 25. Once I've got that 25, I can figure out how many people chose drama and home economics by subtracting 15 and 25 from 60, and I end up with 20. We're told that no student chose both drama and law. So where drama and law intersect, we're going to end up with a big 0. Finally, the probability that a student chose music and law is 0.05. So in set builder notation, that's probability of music and law is equal to 0.05. Now, since that's talking just in general, we weren't given any situation, so we're back to working with just the total number of students. So the number of students who chose music and law is 0.05 times 200, which is equal to 10. We can now go ahead and try to fill in the rest of the table just using subtraction. So in the music column, we've got 50 minus 25 minus 10 gives us 15 remaining. In the totals column, we've got one entry missing as well, so we've got 200 minus 120 minus 50, which is equal to 30. Once we've got that 30 in place, we can now figure out what's missing. The drama and the biology will be 10. We can then go ahead and figure out the total column for biology, or the total row for biology, and that will equal to 50. And similarly, the law row we can figure out very quickly to be 90. Once we've got our table, now we can go ahead and figure out the final probabilities that they're looking for. Part B, what is the probability that a student chose biology? Well, that's fairly straightforward. We're working with the total from the biology row divided by the total number of students. So that's 50 out of 200, or 1 out of 4. Part C says, what is the probability that a student chose both drama and home economics? 20, again, out of the 200, because we weren't given anything, so we weren't restricting or adding any constraints. So that's 20 out of 200, which is equal to 1 out of 10. Part D, given that a student chose biology, what is the probability that the student chose art? So the probability that the student chose art given that they chose bio. So if we're given that they chose biology, we know we're working with a total of 50, so that's our denominator, and the probability that they chose art is 25 out of those 50, or 1 out of 2. Part E says, what is the probability that a student chose home economics given that they chose drama? So probability of home economics given that they chose drama. So we're given drama, we're just looking at the drama column. So we've got a denominator of 30, and our numerator is 20, which can be reduced down to 2/3.